Welcome to Pre-Commit to Better Code. I'm Stefanie Molin. I'm a software engineer at Bloomberg in New York City. I'm the creator of the NumPy doc validation pre-commit hook, which eventually led to me becoming a core developer and maintainer of NumPy doc. I've also created some other hooks, including one that strips EXIF data out of any images that you want to make public. I'm the author of Hands-on Data Analysis with Pandas, and I did my undergrad in operations research from Columbia University and my master's in computer science from Georgia Tech. So we covered this, so hopefully everyone is some familiarity with Git, right? These are basically like all you would need for following along here. It's the basics. If you do have any issues, though, feel free to call me over when we do the coding. And definitely have an editor open. I'm going to be showing with Visual Studio Code, so if you happen to have that, then it should be very, very easy to follow along. But if not, I'm sure we can figure out what needs to happen. Okay, so we have two parts today, and we'll see how the timing goes. If that's straight down the middle, it's kind of depend on you guys and how new you are to the tool. So the first half is going to be how we set up pre-commit hooks on a project. So taking advantage of existing hooks that people have made and then applying them to our project. And then the second half, we are going to focus on how do we actually create our own pre-commit hook. Let's say we have certain code quality checks that we want to run on our own code, and then we can implement those and have those run. So for the first half, we'll do actually how do we use pre-commit and then pre-commit hooks. We'll see the difference between those two terms. Okay, so I want to start by talking about Git hooks. So far I was saying pre-commit hooks, right? So in order to understand that, we need to understand that Git actually has a hook system already built into all of your repositories. You've maybe never looked at it or seen it, but it's actually already there. And the way you can plug into this is that you can add scripts and have them triggered on certain actions in the repository. So pre-commit is a script that's triggered as the commit is happening, but before it's officially made into the Git history of your repository. And there are several other types as well. They can be client-side, like we're going to do with the pre-commit, but they can also be server-side, for example, like blocking someone from pushing something up to the server, or then on the server to take an action. And these are, again, stored in every Git repository that you have. The second you do git init, or you've cloned something down, these are now present on your machine. So it's in this directory .git/hooks. So I want to take a look at that now. Okay, so here I've cloned the repo that I sent to all of you. And I've made a branch SciPy, which I will push up in a little bit. But first, I want to show you what I'm talking about here. Okay, so if you were to run this on your machines or on any Git repository you have anywhere on your computer, you will see something like this. So we have all these files end in .sample, and that's how Git knows not to run them. But if you peek inside of them, it's an example, right, example of what a hook could look like for each of those. Right, so we can actually take a look at the one called pre-commit, which runs on the pre-commit phase. Okay, so we see it's a shell script, this bit at the top, right? And they say that it's an example hook script that you can use to verify the contents. And it tells you a little bit about how this will be invoked. So for example, when you do git commit anything, this script is going to be run, and it's not going to receive any arguments. Okay, then the hook is going to need to exit with non-zero status after telling you what's wrong, if there is something wrong, and then otherwise it exits with 0, indicating that everything's all good, the commit can proceed. And then you can see right here the key thing. To enable this hook, rename this file to pre-commit, so basically dropping the .sample bit, and then it's an executable, and then it sees, oh, okay, I should run this at the pre-commit phase. And then they have an example check in here, but that's not really important. You can look at like what they're actually doing there. So I want to show you how we would plug into this system ourselves. So first thing we could do is I'm just going to copy the file to a one that is without the sample. Okay, so I'm just copying it over. That's so I don't have to change the permissions and mark it as an executable and all that shit. Just faster to show you that, but you don't need to copy an existing one to do it. Okay, and then I'm going to edit it. Okay, so we've already renamed it, right? So this doesn't matter anymore. And I'm going to add a simple thing in here. It's going to say, this is read only, no commits allowed, exit 1, okay? I'm just going to save time and not delete everything below that. But once we're all convinced that once it echoes, it hits exit 1, nothing else runs. Yes? Okay, cool. So that script is now there. And if we, again, do tree on the hooks, we have this one now. So this one is going to run, okay? It doesn't have .sample, so Git is now going to see, next time I commit, do I have a pre-commit script to run? Oh, I do. Okay, I better run this, okay? So now I want to try to commit something. So here I have an unstaged, untracked file, which is the slides PDF that I mentioned before. So I'm going to add the slides. Okay, and it's staged, ready to be committed, right? So now I'm going to say add slides or PDF. Okay. So anyone who's run commit before knows that it's clearly that looked different than normal, right? So we see the message that I put in the script to echo, right? Read only, no commits allowed, right? You can also see, probably it's a little small, but right here, this arrow is red. That means the exit status was non-zero. It failed. If I do git status, right, nothing has changed here. The commit did not happen. And in fact, if I keep trying it, it'll never work, right? Because that script is always going to run and it's always going to block me. Okay. So we're convinced that git hooks work. Yes, they block things. Okay. So now I'm going to remove the hook that we just made. Okay. How would I remove the hook? I could rename it to .sample, or I could just delete it, right? Yeah, so I'm just going to delete. And in fact, it doesn't have to be .sample. It's just anything that is not the exact pre-commit, nothing else will prevent it from running, right? And so that's also an interesting insight to keep in mind about how Git works with here, right? If you can only have one thing that matches the name exactly, then you can only have one script to run at each of these phases. So if you want to have 300 checks, you have to code them all perfectly into that one script. So now you're starting to think, oh, okay, this seems a little hard to get right, or like cumbersome. The other interesting thing is, did you see this on GitHub? Right? If you look at the GitHub for the repository, it's not there, right? So this is something that only exists on your machine. Okay, so that's important to know. So let's delete this. Okay, and if I look again, it's gone. Okay, so now I should be able to commit. And it works, right? So now that blocker is not there. This is what we're used to, the workflow that we're used to. Okay, so I'm just going to push this up. Okay, so I will try to be good about pushing up throughout, but at least you have the slides now in the SciPy branch if you check that out. Okay. So now that we've covered that bit, okay. So as I was saying before, right, we have one hook script that can run per repository, right? So there's only one file that can be created at .git/hooks/precommit, right? And we saw that when we ran git commit, it was automatically triggered for us because this is a system that's already built in to Git repositories, right? And then typically for a pre-commit hook, this is where you would be doing things that are fast, like enforcing your coding standards, linting files, like removing unused imports and handling like no trailing spaces, things like that, and formatting of the code. And yeah, so it only runs quickly. And then what we talked about before, that the commit is going to fail if any of your checks fail. That's how you want to set it up. And that's also why if you're writing all of it in one giant script, it becomes a little difficult to make sure that you have everything coded up correctly. Okay, and we went through this already. So the first one was what we did, step one, right, or option one, which is if you wanted to enable pre-commit hooks, you can do what I just showed you. You go to the .git/hooks directory, you create a file called pre-commit, you make sure it's an executable that can be run, and then you have to make sure that that file is safe somewhere. If you delete that repository and later on reclone it to your machine, that file's gone, right? It is not in version control. So the other option is that you could use a tool like pre-commit. So here's where the naming is very, very unfortunate. So they named the tool pre-commit, but it has more than just pre-commit hooks. But that's why I wanted to distinguish between Git hooks having a pre-commit thing, and then now you understand how this works. It's not pre-commit that makes this possible. They make it possible to do it easier, but Git hooks is what's happening under the hood. That's all through Git that this is happening. Okay? And what's very nice about doing this with pre-commit is that it's very easy to combine things and move them around, kind of like Lego blocks, because you're just using a configuration file. And the other thing is this file can then go in version control. So then everyone using the repository has the same set, and it's not a matter of trying to sync everyone's local machine to have that particular version of the hooks in the .git hooks directory. So they would just pull the changes, and then everyone has the new configuration for the pre-commit hooks. Okay. So pre-commit, the tool, is a multi-language package manager for pre-commit hooks. Okay. It is going to install its own script as the pre-commit hook in .git hooks, and we'll see that in a little bit. And then once that's installed, Git will run the pre-commit script, which in turn will run the hooks that you define in the YAML. So you're letting a middleman take care of all this, and then you don't have to worry about editing the script, and you get to have the benefits of having the actual checks that you're defining in version control. Okay, so in order to start using pre-commit, you have to install this package in your repository. So it's just installing pre-commit. Then you would define the checks in a file that's going to be called .precommitconfig.yaml. It doesn't have to be called that. You can do it, call it whatever you want, really. But then you have an extra step of telling pre-commit where the file is, and that's most of the time not worth it. And we will just show it with that standard name. And then you would have pre-commit install itself as your pre-commit hook, which is what we were talking about with the Git hooks part. And then you would just work on your code as usual. At that point, you never have to think about the Git hooks side ever again. It just automatically happens for you. So to actually install the package, we would, if you're using pip, do something like this. In your virtual environment, you would pip install pre-commit. If you're using UV, you can do something like this and install it as a tool. And there's also this extra bit here where there's another package that wires pre-commit to use UV, so it's a little faster instead of under the hood using pip. Can I get a show of hands? Who's using UV in here? Okay, good. So then I won't use it. I'm just trying to figure out which one should I demo with. Okay, so I'll demo with the pip stuff. Did everyone create a virtual environment on their machines to play around with? Did anyone not create the virtual environment? Okay, so everyone has one. Cool. All right, so let's go and do that now. Okay, so I'm going to use a pre-built Conda environment. You can do it on CodeSpaces because CodeSpaces lets you commit. You should be able to follow the same steps, but you have to make sure that you've forked and you're using the code space from your fork, because it won't let you commit to my repository. Okay, Has everyone activated their virtual environment? So once we have that activated, we will do Python 3 and pip install pre-commit. Okay. Is everyone able to do that? Afterwards, you should be able to do pre-commit -- version. I put the install command at the bottom if you need it again. Is everyone able to install pre-commit in your virtual environments? Can you raise your hand if you had an issue with this step? No? Okay, cool. So now that we have that installed, we now move on to how do we tell it which hooks we want to run, okay? So we're gonna create our configuration file. This is the pre-commit config YAML file. And this goes at the root of your repository. And here's just an example that we'll be working with of what it looks like. So you have a repos section, and this is where you specify which repositories you want to use. So not like which packages or anything, but actual repositories that can be cloned from somewhere. It doesn't have to be GitHub, it could be GitLab, Bitbucket, whatever, but they have to be able to be cloned. So the repos is a list, and each repo itself will look something like this. So we have the link of where it can be cloned from, the URL. We have rev, which is the revision or where to clone it as, so the tag or a commit hash you could use here. And then specifying the actual hooks that you want to invoke. So you, at a minimum, need to declare the ID for each hook you want to run. And these are all hooks that are defined and exposed from the pre-commit hooks repo up here. And in the second half, we'll see how that actually happens and how those are declared. Okay, so let's create this file. So we can just copy this. Okay, so .precommit config.yaml goes at the root of the repository. Okay, and it looks like this. And again, I would recommend copying out of the slides versus trying to copy up here, because you're not going to be able to type fast enough. Also, to get you started, I mean, the logic here is outdated, but if you do pre-commit sample config, you can copy this bit. But if you look at the two, like, they're using a very old version here. So you would have to update that, and then you'd have to update the actual hooks. But you can start with that. Okay, so everyone have that file created? .precommit -config.yaml. Right, and you notice the location, right? It's at the top of the repository. So now that we've installed pre-commit, right? We've created the config file, and now we just need for pre-commit to install itself as the git hook that we're going to use for pre-commit. And to do that, we do pre-commit install. Okay, and you see what gets printed down here. Pre-commit installed at .git/hooks/precommit, which is what we were talking about, that special file that allows us to plug into the git hook system. So if we take a look at this file now that we've had pre-commit created for us. Okay, so this was the file that, yes?
I think I missed a step because when I put pre-commit install, I get command not found.
Okay, did you do the pip install?
I did. Oh, never mind. I think I know what's wrong.
Okay. All right, so if we take a look at this file, so this is that pre-commit file that a new one that was created, right? So what we saw before where I did the echo read only and then exit one, this is the same type of file. So this is an executable that Git will call when we run git commit. And we don't need to understand all of this. The important things to see, for example, is pre-commit is specifying which Python interpreter should be used to run the hooks. And then you can see here it's also saying which config file has our hooks in it, which was that file we just created. And then this is just a bunch of logic that allows it to run or whatever. But you can see that it's now hooking into that. So now when we say git commit, git is going to call this script. This script is going to call the pre-commit tool, which is going to run our hooks. And you will never need to edit that file. I just wanted to show you what's going on. Yes, there's a question?
What command did you use to create that file?
I didn't, I just did this. Yeah, so you do not create that file and you do not touch it. But that's what's happening under the hood. That's how it works. Okay. So was everyone able to get to this step where it is installed and you see this? Okay. Okay, so now we're going to make our first commit, and we need to actually add that YAML file that we made in our commit. So we can do that now. So if we, again, do git status, right, we see that that file is ready to be staged, so we can add that. Okay, if I do git status again, now you see the file is staged to be committed. So I'm just going to say git commit, add pre-commit config.yaml. Okay, and so now we already see something different is happening from the usual, right? So instead of the commit automatically succeeding, pre-commit was run beforehand. It was invoked from the git hooks system. And we can see a couple of things happening here. And those are all successful. So down here, we see the commit message that we would usually get back, right, if we didn't have it.
Okay, I'm guessing I did something wrong, but it says to me fixed end of files failed.
Yeah, so that means that your config is not valid. You have invalid YAML, because so it failed on check YAML. Which, did it fail on the check YAML line?
No, it failed on the end of file fixer.
End of file fixer. Yeah. Yeah, so that means that you don't have the new line at the end of the file. See, if you just add this, it will automatically, I think, fix it for you, I think. And then you can just add it, git add again, and then git commit. Yeah, so that's also the beauty of it, is most of the time it can fix the things for you, and then you can do like git diff and see, and we'll do that later. and then you can see what it was changing on your behalf. Okay, so this part I want to talk about. So we saw something like this being printed first. So the way pre-commit is running things is actually creating its own virtual environment for each of these tools that we're invoking. And so the first time we use the tool at, say, version 5, right, it has to create the virtual environment with that tool at version 5. But then every subsequent commit that uses that same configuration does not need to go through this step. So you'll see that the next time we commit, those lines won't be printed because it will already be there. That repository will already have its own virtual environment prepared. Now, when you change the version, or you upgrade the version, then this step has to happen again. So you will always have a slower round the first time you edit anything in that file. And then we saw this bit, right? So you can see the first one was skipped. Does anyone know why that first check was skipped? You were right. There is no TOML file in the commit, right? So there can be TOML files in the repo, but this is only going to run on the files that you are committing. So the only file being checked for this commit was the YAML file for the config.precommit config.yaml. So the second you edit another file, then let's say you edited the pyproject.toml and tried to commit it, then you'll see that one run, but not the YAML. So that's also something we'll cover later, is that you can specify which types of files you want these hooks to run. Sometimes the hooks themselves declare that they only run on certain types of files. Like this would be quite silly if they let the TOML check run on any type of file and then you're sitting there trying to debug why it's not valid TOML, right? So instead they declare it this way. But if you might have a hook that you decide, or maybe something like Prettier, which does formatting for like Markdown and HTML, CSS, JavaScript. Maybe you decide you don't want it running on Markdown files, and you could customize that on your end. Okay, so this brings us to our first exercise, right? So right now, we're only using hooks provided by the pre-commit hooks repository. And I mentioned that that repos section is a list, right? So if go down here, this is a list. So in YAML, anytime you have this, these are members of the list. So we're only using this one repository, but there's many, many more that are provided. And we're going to see how we use, jumping ahead. That's a future exercise. So right now, I just want you to take a look at this link right here. So if you can actually just copy this, and you can go to there, and you can see, try to find some other hooks that they have, so ones that are not up here that you think are interesting, and add them to the config and commit them. Personally, the ones I started us off with are ones that I always use in almost every repo, because if you're making anything with Python, you probably have a Py project, so you have a TOML, right? And you want to make sure that's valid. If you're using pre-commit, you're going to have at least one YAML, so those two off the bat, and then the line endings, right? That's like if you're doing pull requests, you see a lot of those. But yeah, like you do have to be careful, right? You can't add every single possible hook just because it might apply in like this one edge case that might come up in 3 years from now. But in general, like you find the ones that make sense for the types of things that you're working on. So that sounds like a very, very good example for that type of thing. So the ones I put here, just as an example, I'm not going to go about actually adding them, are related to shell scripts, right? So two things you have to do to make sure that your shell script is actually going to work is you need to have the shebang at the top. So the first one checks that executable files actually have the shebang saying how to run it. And then the second one is the reverse, saying if you have the shebang, make sure it's actually executable. And that was actually the reason why I just copied the existing pre-commit sample and edited it, because it was already had the shebang and it was executable. Saved me the steps of doing that myself. But if you have any kind of scripts that you're going to be adding to your repository, bash scripts or something like that, then adding these is a very quick sanity check, and you never have to worry about committing some script and then all of a sudden someone tries to run it and they invoke it differently and now it doesn't work for them, and trying to figure out what's going on there. So yeah, like I said, I'm not going to add it to this one because we don't have shell scripts, but those two work well together, I'm saying from experience. Okay, so now I want to talk about using third-party hooks. So I'm calling them third-party because they're not provided by pre-commit themselves, which is what we just looked at. And In the past, they used to have on their website, not exhaustive, but it was basically anyone who had said, here, I have a hook, here, can you put this up there? And it would have that list. They got rid of that, and so now you have to search kind of the global all of code type of thing across GitHub or whatever alternative hosting. And so they have some guidance on like specific things you can search for that will tell you that the requisite file that needs to be there to declare a hook is present, and so you would know. And we'll talk more about that file a little later. And we're going to just focus on adding rough here to do the linting of our files. Okay, so we're going to add the rough to the same pre-commit config.yaml file. And as I mentioned before, the repos section is a list of repo segments, right? So this everything that's grayed out up here is what we already have in our file. And then down here, this is the new piece that we're adding. So it's another repo, right, where it says it's the rough repo this time. So you can see that now, instead of saying the pre-commit user or organization, it's now Astral SH. And then the repo is the rough pre-commit repo. This, again, we have the version that we're going to use. And then we have the hooks that we're going to use. So we have the rough check one is their linting. And then we actually have some arguments that we're going to pass to that only when it's invoked via pre-commit. And then down here, the rough format is just the rough's formatting side. So they divide the two things. Linting is one tool, and then formatting is the other. Okay, so let's add this to our file. And we just paste it down here. And you have to be very careful with the alignment. So notice how this section, this dash right here, has to align with this one. If you don't, then you have an invalid YAML. So alignment is very important here. And you can have like space between. That's not a problem. I think it sometimes makes it a little easier to read. So for example, like that. But it doesn't matter either way. Okay. So now we can add this. Well, first I'll show you the div. Okay, so that's what we're adding to the file. Okay, and now notice again when we commit this time the first repo that we've declared, we haven't changed anything, so it reuses that virtual environment. But this is our first time making a commit with rough, so now it has to create the virtual environment for rough. And so that's what's happening right here. Okay? And now you can also see that we have two new checks that are run. Rough check and rough format, and those are the two that came from rough. No, so remember that hook file just says run pre-commit with this YAML file. So we only ever change the YAML file. Okay, is everyone getting this on their ends? Sorry? Okay. Again, yeah. You know what? You can configure your editor. I don't know if you've noticed that when I save. So if I go back here, save, it automatically does it for me. That's a huge time saver too. But you can also disable this one, or end of file if you don't want it. Yeah. Okay. So we have that now done. Let's see. Yeah. And so also again, notice no files to check, right? So rough is not working on the YAML file. Okay, so now we've committed, we talked about this already. Okay. So now, as a sanity check, right, we saw rough didn't run, so we want to make sure that it actually is doing what we expect it to do. So we're going to create a file that has issues that rough will find, and then we're going to have it fixed. So here, I'm just going to copy the contents of this into a file called example.py. Okay, now I have to do a special shortcut so it doesn't fix the file for me. Okay, So it's saved. So you see we now have that file right there. So if I add the file and I commit it, okay, so we see things failed, right? Several things failed, okay? First, it didn't like the end of the file. That was fixed. Then rough came and found an unused import, right? RE, I'm importing RE here, but I'm never using it, so it doesn't need to be imported. And so rough is telling me that with this issue right here, where it reports the unused import. And so rough actually, the rough check logic removes that import. And what happens if you remove that import line? What's the first line in this file then?
And that function call.
No, that's the second line. What's the first line? A blank line, yeah. Is that something that would pass through linting and formatting? No, definitely not, right? And so that's also why you want to have it like this. So you check the file, it removes things, and then the formatting will reformat afterwards. So basically, rough check sees RE, says that you're not using it, removes it, and then rough format says, oh, you're starting with a blank line. That's not good, and removes that as well. So those both get removed. And I don't know if you saw it quickly, but you can see here, right? This file was edited. I didn't touch this, but these were all the changes that the hooks made on my behalf, okay? And you don't need to open the file and scan it to see what changed, right? We could, again, if you see git status, right? The green part was what we had. Those were the changes that we staged. And then the red are the changes that the hooks made on top of our file. So that means that we can just do git diff, and we can see all the changes that the hooks made, right? Removing the unused import, then removing the blank line that would have been at the top of the file, and then finally adding the new line down here. Okay, so the hooks, while they make changes to your files, they're not making them and then committing on your behalf, right? So it's important because maybe you're bumping across a rule that was enabled and you actually don't agree with it, but it's just a very rare circumstance that has happened at one time in your code, and you want to be able to check to confirm that it's not that you need to adjust your settings, that you actually do agree with the rules and how they're being applied. So in this case, I'm sure we'd all agree that the changes were correct in this case, and so we can then again stage those changes, and then we can commit. And this time it works, right? Rough is still checking the files, right? We still see passed in both cases, but there's no more issues with it, and so it allows the commit to go through. Okay, that's just a summary of what I was saying. And yeah, we have this. Okay, and so now we're going to do another exercise. And so this time we're going to add a different third-party hook. And this one is checking doc strings. So you can go to that URL and then you can read about how to add it. And usually there's a thing where you can copy paste. So you'll copy paste into your YAML file, set the version to usually the latest version of that hook. And the command that I have on the bottom is something that you can use to validate that the YAML is correct. I think one or two of you already had an issue where the YAML was incorrectly formatted, so like a tab was there where it shouldn't have been. It does a very good job at telling you something's wrong, but the way it tells you what is wrong is super cryptic. So if you need help deciphering that, please let me know. And also, if you were curious what I meant about like those cryptic errors, try just adding like an extra, tab before this, and then running that, and then, maybe I'll just do it for you now and you can see what I mean. That didn't even work, that's funny. Huh. I wonder if they broke that. There you go. Would you have thought that that's what that was? right? So basically, if you ever see some weird thing like this, it means that your config is messed up, and just, look over it. Like, is this correct YAML? Is everything aligned correctly? Yeah, because it's very non-obvious. Okay, so just that. Okay, so just like you've seen for the other ones, basically, you will have some snippet like this on almost every repo that exposes a hook, and you can either just copy and paste it directly, or maybe they tell you, here, put the version here, and then you just have to figure out which version you want to use. So I know we made a release on this recently, so it's actually 1.9 is the latest, but you can use whatever version you like. And again, we just paste it below. So here, this would also have made an error, right? So, yeah. Right? So this one, just because the alignment's off, right, and it's not expecting a list at that context, it gives you the cryptic error, right? So we just fix the indentation, and it's valid, right? So we can commit those changes. And again, right, new hook was added, so we need to create the virtual environment for that hook, but we didn't touch the other ones, so we don't have to create them all. Okay, let me just push, I haven't pushed it. Okay, so if you wanted to consult what I had, it's on the SciPy branch, I just pushed it up. Okay. So now let's talk about how we can run the hooks on demand. So we saw the issue before, right, where we had that check toml and it didn't check the Pi project that was already existing, right? So how do you check, for example, files that you haven't changed, but you want to make sure that the new hooks you have added still have that file passes, right? So that's one use case. Another one is like you're evaluating, I want to add this new hook. Is this actually the right fit for my code? Then you can also do it without actually making the commits. And so the way this is done is you invoke the pre-commit executable directly. So you just say a variety of ways that you want to run. You can say pre-commit run, and that's going to run on all of your staged changes. So after you've done like git add, anything that would be showing up in the green in there would be something that would be passed through to all of your hooks. You could do something like pre-commit run -- files, and then you can enumerate each of the files that you want to run on. So in this case, it's going to run all of the hooks on only the example.py file. And the final thing you can do here is you can be specifically saying which hook. So if you say pre-commit run, then the ID of the hook, right? So IDs are these lines, right? Wherever there's an ID, that's the name that you would use. So you could say rough format, rough check, etc. And then -- all files says to run on all the files in the repo, but we're only running the numpy.doc validation hook. So you can, use whatever combination of that makes sense for what you're trying to check, right? And there are definitely use cases for all of them, which we'll talk about, right? So for us right now, we're going to do a combination of the last two, right? So we added docstring checking, and right now the only Python file is that example.py file that we added. So we can check that its docstrings look good. So we can do pre-commit run numpy.doc validation. So that's the hook -- files example.py. Okay. So first note, all the other ones, remember we always saw multiple hooks? This one, we only said to run numpy.doc validation. So that's the only one that ran. And right, we didn't add any changes. We didn't stage anything. We didn't say git commit. We're doing this outside of that process. We're just checking the file. You can also think of it as like if you had just invoked a linter or a formatter on the command line. It's the same type of thing. It's outside of the commit process. And here we can see that this check would fail. But since we have no changes to make on that file, we wouldn't have been able to invoke it with the git hook system, right? There's nothing to commit. So this hook is not going to make any changes to your file. It's just saying that, hey, you need to address some issues in the docstring. And you notice that it's finding quite a bit, right? So it's saying that the first one is saying that the module itself doesn't have a docstring. And then the remaining ones are all concerned with the with the function itself, right? So there's no module docstring, but the example function, my function, does have a docstring. It's just missing information, right? We have a parameter a, but we have no idea what it is. We don't know what the type is, what its purpose is. And it's also saying, maybe that it should have a see also section or an examples section. But again, no changes, right? There's nothing, we didn't change the file, right? So the only way to invoke the hook on the existing files is to do it that way. Okay. So we saw this. So now I want to talk about how we can modify the behavior of that hook, right? Maybe for something like this, right, maybe we don't care about having a see also section or an examples section. And so we want to tell the hook that don't block my commits for these types of issues, but still make sure that I have doc strings and that I'm at least documenting parameters, something like that. So there's two ways that we can do something like this. One is like command line arguments, which is what we saw with the rough configuration. If you look at the pre-commit config, right, this bit these are command line arguments that are getting passed when rough is invoked. So that's one way. And the other way is to put things in a configuration file. So one option being, if the tool supports it, you can put the tool's configuration inside your pyproject.toml, and then that will automatically be used when this is invoked. Right, so again, this is what rough is doing, right? So when we call the rough's linting, we're telling it -- fix to make the fixes for us, and then exit non-zero on fix, and that makes sure that the commit fails, which is what we want, and then show fixes so we can see what was changed, so we can go back later. Okay, now there's also rough configuration that can happen in pyproject.toml, so they also support this. And the difference is that while whatever is in the pre-commit config YAML is only run when rough is run by pre-commit. If you run rough on the command line, it's not using those same arguments by default, okay? If you run rough automatically on save in Visual Studio Code, it's not using those arguments, okay? So if there are common settings that you want every time you use that tool to be using, then you want to put them in the configuration file. And so here I have that for inside pyproject.toml, so that when I'm using these settings in VS Code, then it's automatically preserving them, and I don't have any conflict between, well, VS Code liked this change, but pre-commit blocked it because it doesn't have those same settings. So they'll be in agreement on that. So settings like the line length, I want to allow 88 characters. I want to use spaces instead of tabs. I want to use single quotes instead of double quotes. And then the specific rule set to use, which rules to ignore. These are all things that you want consistent across every use of your project, right? Or every use of these tools across your project. You want it to be consistent. So all we have to do is copy this logic. And now we're going to open up the PyProject. And you can just paste them at the bottom. Okay. So if I just this. Okay, you can see they are now at the bottom, pyproject.toml. And rough will know to read these out of here. Okay. So now, let's commit those changes. So again, this is the only change that we've made. And so now we're going to do the same type of thing, but for the NumPy doc validation to ignore those specific checks that we don't want to prevent the commits from happening. So I've listed out the ones to ignore. So you want to do ES01. You want to do EX01, which is the examples section. This is the see also section. And we also want to ignore this one. And you can see how to do that on that page in the documentation. Okay, so when it comes to any tool like this, you just have to go through the docs and figure out what it wants this section to be named. So basically, the tool is going to be looking for something in the pyproject.toml. And so this tool in particular is looking for a table called tool.numpy.validation. Okay, so we can just copy this and paste it into pyproject. Okay, and just to go over a little bit of what this is. So basically, we're declaring which checks we want it to report on. And the way the tool works is you have to say all, you want to run all, and then which ones you don't care about. So it then removes these. And these are the ones that we talked about before, the ones we want to remove. Okay, and then with that in place, if we were to just run, okay, so now if we just run it, we see that we have the two issues left that we do care about, right? We want to make sure that we have a doc string for the module, and we want to document what that parameter A is doing. So now we would go and update this. So I'm just going to copy these changes. Okay. And now if I run this, it will pass, right? So this was the module doc string, and we added this section here describing parameter A. And so that's enough now to be a doc string that will pass through the checks. So we can now commit these changes. Okay, and everything passes now that we've made those changes. Okay, so before I talked about how these hooks, especially you can see right here, right, this no files to check, right? So there's already this capability of the hooks to determine which files they will run on versus won't run on. But we also have that ability ourselves. So we can say things like, don't run on any file paths that look like this, or something like don't run on any markdown files. So for this example, we can tell the numpy.validation hook that we don't want it to run on certain parts of the code base. So for example, we might want strict docstring checks on stuff that will end up in public-facing documentation, but maybe the test suite doesn't need to be as rigorously documented. And so we can specify something there. And so the way this works is there's an exclude field that you can provide inside of the hook, right? So hooks has a list of hooks, and everything under this little bit here is belonging to that particular hook. So numpy.validation, we will have exclude logic, and this has to be a regular expression. So this is saying any paths that start with tests or docs, any files in there, don't run the hook on this. Okay, so we can add this to our pre-commit config, like that. And then what we can do is, just to show how this is working, we can create a new folder. We're going to create a tests folder. And then in there, create a new file, testcheck.py. Okay, we can leave it blank. And we can commit that new file. So we're going to add tests and okay, so that would be our new file that it should not check, right? But the file is empty, so it's obviously missing the module doc string at a minimum, right? So if it were running on that, we would get an error. But if it's successfully ignoring it, then the commit will be successful. So. Okay, commit passes, right? Notice how it says no files to check. So that was definitely a Python file that it would have looked at, but the exclude logic here was matched, this regular expression matched, and so it ignored the file. And that's how we can tell, one of the ways that we can tell pre-commit not to run certain hooks on different files. Okay, and then I'm not going to show an example of it, but like the opposite, if you wanted to say like I want to run on these types of files, that's with the files option that you add. The same way as exclude, you just swap out for files and you specify the types that you want to have. Okay. So I also mentioned earlier that the NumPyDoc hook has been updated since the version I showed in there, where it was 1.8. And particularly with rough, you will find that pretty much every week your hooks will be out of date and you will need to update. And so there's a very easy way to do this, but it does come with some caveats. So pre-commit itself has the auto update option. So if we run that in here, we will already see that we're out of date. So pre-commit auto update. So what this is doing is it's going to each of these repositories and checking if there's a newer tag that exists, or if you're using commit hashes, a newer commit hash. And you see that the first one, the pre-commit hooks, it didn't find anything new, so it left it as it was. But for both rough and NumPyDoc, there were newer versions, so it updated that. Okay, so if I do git diff, you can see it actually made the changes in our pre-commit config for each of those versions. Here's the rough version, right, and there on the bottom is the NumPyDoc version. Now, you have to be very, very careful with this, especially those working in corporate environments where you might need to be consuming from a mirror. This might have just been updated an hour before you ran this command, and pre-commit is going to probably find that there's a newer version, but then you won't actually be able to run it because it won't have been available to you internally. So this is where I like to combine it with the pre-commit run on all of the files. This way you make sure that all of your hooks are run at least once, and you can easily see, oh, it wasn't able to create the virtual environment. For rough, that means it's not available internally yet, so I shouldn't go that high of a version, and you can scale it back as you need to. So this is what I was saying. So pre-commit run -- all files. Right? So it changed the versions of the rough pre-commit hook and then NumPyDoc. So both of those environments need to be recreated, right? And as I was saying before, if it's a situation with mirroring, right? If it's not mirrored internally, that step will fail because it won't exist, right? That's like trying to pip install a version of a package that hasn't been published yet. It's going to fail. So if this succeeds and everything passes, then you know, okay, I can update the hooks. The other reason to run this command before you actually commit these changes is maybe a new rule was added or they changed the behavior of a rule. And maybe now you don't agree with it and now it's making changes to your files. You want to be able to visually inspect that you agree with the changes that are going to be happening on the pre-commit side. So you would run that, and then at this point, seeing everything pass and everything worked, we can make the commit. So update hooks. Okay, and so now we've made those updates. Okay, so the other thing I want to cover here is that sometimes you do need to bypass the hooks. A good example is like you're just working on something, you're just experimenting if something's going to work. Maybe you don't want to be going through and making extensive doc strings for something that then, a day later you've ended up scrapping the entire thing. That's a lot of wasted effort. And so what you can do is pass -- no verify when you say git commit, and that tells Git not to run the hooks at all. So you can first maybe try the commit, see what it's going to find, and if you agree that everything there, you'll address it later, then you can do no verify. So let's see how that would look. So if I take example.py, and let's say I don't want to document parameter A because I don't know what it is yet, so I can save it back like this. And we already know that this would create an issue, right, if we tried to do it. But let's just say I really want it that way right now, so I'm going to do it, just force it to commit like this. Okay. So again, we'll confirm that. So simplify. Okay, right? We confirmed that it passed. Also notice the output's different, right? So you can see that the version was updated. Okay, so that's not working. It's not going to let us through. So if we just do no verify, it works now, right? None of that logic was triggered, and you now have bypassed it. Okay, and again, now when you finalize the implementation, we know what A does, then we can go back and document it. So this is also nice to have in combination with like CI, because then at the point where you're making the pull request, you want to make sure that the documentation is there, but you don't need to be doing it for every minute change until you've settled on the implementation. So know that that is an option. Okay, and one thing that we didn't cover in here, but you can go to that URL in the documentation. So basically all these hooks by default will run at the pre-commit stage. But you can actually, in this pre-commit config YAML, there's a spot where you can say that this hook should run as pre-push, for example. So maybe there's a hook that takes a little too long, that would be too annoying to run on every commit. You can configure it to run when someone is then ready to push the changes up. And that pre-commit will take care of installing that in the right spot and getting it to work and whatever. So that's also possible. And we talked about this, like that's where you can see if there's a hook. So if you have an idea for something, right, a good idea is to check if someone has already made it and already exists. And so that's one way you can try to find things. And again, combining this with your CI tool would be the best way to do it. So this is all stuff running locally, gives quick feedback for developers, but at the point where someone has to review it, the reviewer also wants to know that all the code quality checks have passed. And so you can actually run the same logic on both ends, and then it becomes much easier to review those code. So you can either run something like pre-commit run -- all files in CI, or you can also use, they have a pre-commit bot, which takes advantage of some caching, so it is faster, but then you have to have a bot have access. So there's, you have to weigh that balance. Okay, and with that, we're gonna move on to the second section. So this is where there's gonna be a lot more coding time, and you're gonna have to come up with something that you want to build. And we're gonna be creating our own pre-commit hooks. Okay, so first, I just wanna go over like what the recipe is for a pre-commit hook, and then we'll take step by step, building up whatever you guys want to build. So the first thing, and this will be the hardest part, is actually implementing your logic as a function. So figuring out what you want to check for and how you actually implement that code. So given a file, how would you process it and determine, yes, this is good, or no, this is bad? Then you would take that function and you would wrap it in a CLI. So we saw that pre-commit is basically invoking these things with sometimes arguments are passed in, CLI arguments. And so wrapping it in your function in CLI makes that integration possible. Then we want to make it installable, right? So pre-commit was making virtual environments for each of those repos we pointed it at. So your tool will be another repo that gets pointed at, right? And pre-commit will need to figure out, how do I install this and the dependencies it needs to run? And so we'll talk about that. And then the final thing is you actually have to tell pre-commit in a way that it can understand that it is a hook, like what you're building, right? So that was the piece that we haven't touched upon yet, right? How is it that when we point something at a repo and say ID is whatever the hook's name, how does pre-commit know what to do with that, right? And there's a special file that has to exist in repos that make their own hooks. That is what pre-commit will then look for and then find the information it needs to run. And so we'll cover that last. Okay, so for the check function itself, at a basic level, you're going to have something like this. So you're going to have a function that is going to receive, or given a sequence of file names, could be 1, could be 10, whatever, and it's going to return an integer, like an exit code, okay? So it's going to perform whatever check that is. That's however you want to implement it, whatever it happens to be. And if it's determined that there's a failure, you can return 1 or any non-zero. And then if it's success, if your check passed, you return a 0. So that should sound like we had in the beginning where we said exit 1 was an automatic failure. It's the exact same thing. We're not declaring the exit. Pre-commit will take care of that. But 0, 1 is what we want to do here. So given the files, perform the check, return, was this good, was this bad? So here's a toy example where maybe we only allow a person to commit one file at a time, okay? So in this case, we were given the file names, so our check is just checking, were we given more than one, right? If we were, that's a failure and we return 1. So if you have this check, people can only commit one file at a time. So a slightly more complicated one, this would be from a tool I've made for personal use, but it is public, to remove EXIF metadata from images. So basically the files in this case are only images, right? So that's a use case where you say I only want to run on certain types of files. So given some image file, I'm going to run through a check. So here's a simplified version. You open the image up, you check for the metadata that might be in there. maybe you're expecting it to be empty. If it's not, then you already know that that fails. But in this case, you can fix it, right? You can just clear off the data that shouldn't be there. And so you can do that. So when you're writing your hook, you have to think about it. Is this something I can fix? Or is this something I just have to tell the user, hey, this thing's wrong, you need to fix that, like the doc strings. So there's going to be one or the other. If you can fix it, best practice would be to fix it. It's just much easier to have that being done automatically. And then you should also indicate what went wrong or what you changed, right? We saw that rough was saying we removed unused import, right? It told us what it was changing. So in this case, if the image is edited, it should say that it removed that EXIF data from that particular image. And then we're just keeping track, like did this fail or not? Was something changed? If it had to change the metadata, that means the hook should cause the commit to fail because you were trying to commit something that wasn't allowed. So important to consider, like when you have this idea, like what actually makes a hook helpful. And big thing is that it has to run quickly, right? You might have some super important check, but if it takes multiple seconds, 10 seconds, 20 seconds to run, you might start using it initially, and after a while you're like, oh my god, this takes so long. Every single commit, I do this. And then you're going to start no verifying all of them, and then that defeats the whole purpose, right? So you have to think about what makes sense to run at the pre-commit stage, like on a developer's machine, versus running in your CI where those can take longer. So think about that when you're writing your hooks. And you also want to be explicit about what went wrong, right? So in the case where it fails, it's very helpful if you're saying, which file it was, which line number it was, what exactly was the issue. Like you've seen rough had error codes, right? It's like F401 was unused import, and we saw NumPy doc also had codes. I mean, you might have one thing you're checking for, and in that case you don't need a code, but you should say, this XYZ is wrong with this particular line, right? So that it makes it easy for someone to go in and fix it. And if you can fix it, then just fix it for them. Okay, so now we're going to take a bit of time here, and I want you to come up with your own check. So hopefully you came in with some idea that you wanted to do. It doesn't matter if it already exists, right? So maybe you want to not allow print statements to be in the code because you want people to use logging. Maybe you don't want people to commit files more than 1,000 lines or files bigger than a certain size. You can kind of do whatever you want. If you don't have anything in mind, the example I'm going to be showing is how to check file naming conventions. So if you have a certain way that you want things to be named, you can also do that. So yeah, think about that. And if you need third-party libraries, go ahead and use them. We'll define how those get installed. So you basically, as if you were writing a script for yourself to do this check, whatever you need to make that happen. And then put the code in that directory, which is already in the repository, so src custom hook check.py. And beyond that, you don't need to do anything else. Just confirm that your hook exists, and given a file, it works. Okay, so for this, as I mentioned before, I'm going to be showing with file naming conventions, and particularly, we're going to just check that the name is long enough, so not allowing someone to name like x.py. Okay? What? Are you got it working? Okay. So, let me see. Yeah. So here I have an example solution to do this type of check. So I'm going to use pathlib to read in the file. So I have from pathlib, I'm importing path. And I also want to say here, like this was not the signature that you perhaps worked in yours in the example that I showed, right? So in the initial example, I was saying you get in a file name and you do something with it. And here I have something that you can configure, and this is going to come in later, right? Because we talked about, for example, how rough lets you set the number of characters allowed in a line, right? Maybe for the person who's working on the comments, right? That percentage that's allowed, that's probably going to be something you want to configure. So the way that you start allowing for a path to make that happen is you add additional arguments that are optional into your signature here for your check function. So here that is this one, this minimum length of 3, okay? And we're still returning the integer. So what we do is we receive the file name, and we're just going to grab the stem, which is the end bit. So if the example was, as you can see right up here, so my/repo/x.py, this just gives us x, okay? And that's the part that we want to check that the name is long enough, right? So we've extracted that here. And then we just have our length check. So it's a failure if the length of the name is less than the minimum length. And then we're going to print that the name is too short. And this is just going to say that the minimum length is whatever it happens to be. And then the file name, that was the failure. And failure is a Boolean. We're just going to convert that to an integer just so that what I told you about the int is true. But you can actually return the Boolean, and because true is, it's going to handle it correctly in Python because they're going to be converted to integers under the hood. So I'm just going to move this into the check function. And I'm going to do some renaming. So I'm going to rename this, instead of custom hook, I'm going to rename it file name validation. And I'm going to rename this the check file to validate file name. Okay. So now I have that check in place. And we can commit these changes. You see, I don't have a doc string, right? So, because I told you about this earlier, we are going to no verify. So this is a great example because, right, we don't know if this is the final implementation. We might want to be iterating on this a few times. So I'm just going to do it that way. Okay, and then we can move on to the next bit, which is now we need to wrap that function in a CLI. So someone will be on the command line calling this function, and it will receive the arguments, which are the file names, and then any of those optional arguments, like the minimum length. So to do this, we're going to just stick to standard library, and in there's the argparse module. And you can pretty much copy and paste what I'm going to show here as like the basics of how you would get one running, and then you can add additional arguments if you want. So we have to import argparse, and then the first thing you have to do is create an argument parser. And here, prog is the program or the name of your hook, so you would just put what you want to call it here. You can call it whatever you want. It has no bearing on any of the other stuff we'll do. It's just like if you ran like -- help, that's the name that will be displayed to tell you about what you're using. So that gives you the parser, and then you have to add arguments to it. And at a minimum, you have to add this bit here, where you're saying that it receives file names as positional arguments, and it can be more than one of them. And then once you have that, then you can parse args on the parser, and you pass in this argv, which you can, again, copy this exactly how it is. So the reason you want to have something like this is that you can then you can actually write test cases, and you can simulate calling it from the command line by actually passing in a list of the command line arguments here. So you don't need to like write, for example, in PyTest, something that would go and use a subprocess to call the thing. You don't need to do that. You would just call main, passing in the list, and then that would get passed into here. So this returns a namespace from argparse, which is args. And for the most part, you can use dot notation to grab the pieces out that you want. So then you would run your check. So that function that you just wrote, if it takes multiple file names, you would just pass args.filenames. Or if it's one by one, then you would just loop over. So if you're given 10 file names, you're going to have to call your function 10 times. And then you'll need to somehow aggregate the results. Right? So you would probably want to use an any. Like if any of these failed, it's a failure. Right? And then the same thing as before. We need to bubble up the 0, 1. Yes?
Oh, okay, I missed the RB. I was wondering where RB was defined, but it's okay.
Yeah. So, like I said, you can pretty much copy this exact thing. You'll just change this part where you're going to say what your hook is, and then you have to define this logic. And if you have like the percentage that must be comments in your case, right, that would be a good use case to have a second argument here, in addition to file names. And the example I'll show, I'll have an additional one for the minimum length that must be in the name. Okay, so now I'm going to show you an example of how this would look for the EXIF stripper. So here, right, as you notice, it looks almost identical to the previous slide, but now instead of saying your hook, it's using its own name, EXIF stripper, right? It's still doing the parse args bit, but I have a function in there that we saw before, which runs on a single file name. So I have to run it on all the file names I'm given, which is that list comprehension there. So that is a list of results, meaning the file was changed or not, so a list of those Boolean values. And then I call any on them. So if any of those were true, that result is true, so meaning failure. And then I call int on true, which becomes 1, and it returns the failure. Any questions on that bit? Has anyone not used argparse before? Okay, so everyone's used it, so it should be easy. Okay, so let's create a CLI for your check function. And you can put it in a separate file like cli.py. So for the file name lengths, right, we essentially, again, just copying over the same stuff, we set a different name for the hook. In this case, it's validating the file names. And then also I have a argument for the minimum length. And this has a default, so if someone doesn't provide it, it's still going to use 3. And then, yeah, the rest is pretty much what I had showed before, right? We are going to call validate file name. We have to pass in that other argument that we created, right? So args.minLength is the optional one. And then we're making, like, it's going over in a loop, right? So that we run on all the files that we received with that same minimum length. And then we combine the results. So I'm just going to copy this stuff into the CLI. Okay, and then I can commit this. Right, doc strings again, and we will verify. Okay. So now we have our check function and our CLI, and now we need to make this installable. Right, so you don't have to make a package for this to work. It can be a standalone script, but either way, you have to be providing the information that pre-commit needs to figure out how to install it. It doesn't even need to be Python. It can be other languages that are supported as well. We have to make sure that we are stating all dependencies. I don't know if anyone in here is using a third-party thing, but I've had people in the past make checks that look at SQL files, and they needed a special library to do that. So if you have anything like that, then you need to declare it, because even though you have it on your system, pre-commit is making its own virtual environment, which will not have that available to it. And also, obviously, other users. All right, so ideally, this installation is going to make an executable that then pre-commit can run. But you can still work with like the Python-m syntax. You can also configure it that way. We are going to make an executable. So I want to talk about structure in the case of a package. So this is using the EXIF stripper example. So it's a very, very small package, so you have an idea of kind of what needs to be in there, but without making it too large. So the repository is exif-stripper. And at that top level, like we saw before, we have the pre-commit config YAML. That's for those developing the package, right? Then we have this new file here, pre-commit hooks.yaml. So this is how we actually configure the hooks that we're exposing in our repository. This is where those IDs come from. So basically what happens when we specify in our pre-commit config file, we were pointing at a repository, and then we named the IDs of the hooks we wanted to use. So pre-commit goes to the repository, checks out the revision that we stated, installs it, right? And then it's looking for this file and checking that the IDs that we have are in each of those. And that's how it figures out how to install for each of them. And then what they run on and all of that. So we'll take a look at that as the fourth step. If you're going to be having any kind of thing that you're distributing to other people, you should have a license and a README in there as well. The package itself, in this case, is using the SRC layout. So we have, just like you have in the repository that we're working with, there's an SRC directory. Inside of that, exif_stripper, and that's the package in there. There's an init, and then the CLI is where all the code is. And then finally, tests, right? You should have tests for this code, especially as you're tweaking things, and then you want to make sure that it does work, or that edge cases like, you know, having the word that you're looking for in the text don't actually cause false positives. And the thing I jumped over is the pyproject.toml. So this is what pre-commit is going to find when it goes and clones and checks out the revision. It's going to look, if it sees this file, it now knows this is Python, right? And it's going to see that it can install with that. Okay, so we have to provide the information in there that says, well, what it actually needs to install. Like, what's the minimum Python version? What are the dependencies? So here in the project, there's a template PyProject, and it's done with the bare minimum stuff is in here, and also there's to-dos of what you will need to replace. So in the project section, there's going to be a name, and that's the name of the distribution. So oftentimes this ends up being the name of the repository, but in this case, it's going to just be custom hook. You'll have the version of the hook. You'll have metadata about the project, so who's the author, what does it do, right? What's the README? You need to declare what version of Python your project will work on. So here this says anything that's 3.10 and above, it'll work. The dependencies is a list of all the external dependencies, so anything outside of the standard library that you need to run your hook. So if you have no dependencies, you can leave it empty, but if you have anything, they have to go in there. Then there's also this newer thing called dependency groups. And so this allows you to bundle things that are not going to be used by users of the package. So like if they're installing from PyPI, for example, these won't be exposed, but people who have access to the code base will likely want to use this. So you can declare something like a dev dependency. So anyone who wants to work on the code base should install the dependencies that are needed to make it run in the first place, which everyone will install, and then the dev dependencies that are needed to develop consistently amongst everyone on the team. So pre-commit would be a dev dependency. Never add it as a dependency itself, right? Because that's outside the system. So it would be a dev dependency, and then something like PyTest, if you're running tests, your test suite, that's also a dev dependency. You don't need PyTest to run your hook, right? You just need it to write the code for the hook and make sure that the code for the hook is still working correctly. And then, since we're making a package, you're going to have information about the build system. So there's, when you build the package, like when you do pip install, so pip is the build front end, and then it has to have a back end that will actually build it. And so this just tells it which one to use. You can just copy and paste that. You don't have to figure out what to put there. And the piece I jumped over here is the piece that will make the executable for you. So there's this special syntax here, and then once you provide this, when you install your package, that executable becomes available. So here's how that looks for the exif_stripper. So you notice that scripts, this word is the same as we had in the previous scripts, but your script name becomes exif_stripper. So whatever value you put there is what you can then run on the command line once this is installed. So think about how you can just run pre-commit on the command line. That's like that. If the same thing if you installed something like black, the same thing. It's defining this entry point here. And then on the right side, we have the location of what code is actually running when you invoke that on the command line. So exif_stripper, the package, dot, the module, CLI, and then the colon tells it this is inside of that. So main is the function to call, and main is inside the CLI module, which is inside exif_stripper package. So you would put the full path to whatever you want to execute. And so we created with argparse our CLI, and we called it main. So you will also have main, and if you named it CLI, you will also have that, but you're going to have your own path to this, and whatever you want to call it, you will place there. Okay, so let's go ahead and do that. And at this point, you will also be able to confirm that you can install your package. Right, so once you add that information to your pyproject.toml and you fill it out, then you can do pip install -e dot and confirm that that works. And if it does, then you can also check that your CLI is working correctly. Okay, so this would be the changes that I would need to make for what I've been working on. So again, I'm changing the name here to call it file name validation. I'm putting my information as the author, adding a description, right? For this check, there's no external dependencies. I'm putting 310 and above, more because of the syntax that I'm using in the actual code. So as long as that aligns, and this is also, again, we're having something in CI confirming that your hook actually does work for all the versions you state it does, is important to have. And then for the actual entry point, I'm creating an entry point called validate file name, and that is going to map to this path within the package, so file name validation.cli, which is the import path, and then I'm going to call the main function that we saw created before. So we can take this and paste this in the PyProject. So I'm just going to paste only over the parts at the top. So from here up, everything else can stay. Okay. So if I do, just show you the diff. Okay, so you can see, again, all the changes that I did make to this file. So the name of the distribution, the authors, the description, I confirmed that there are no dependencies, and then I specified that path to the entry point. Okay. So at this point, we can install. Okay. And then you can see at the bottom, right, it's installed file name validation. So this is the name under project. Will show up here. So file name -validation. I just move this right there. You see that? At the top, that's going to correspond to that. So if you see that means it's found the right thing. And then obviously it's saying version 0.1.0, and that is indeed what is up here. So that was correctly installed. And at this point, you actually have access to your entry point that you exposed. So let me just check. So validate file name. So now that entry point has been created, right? Was everyone able to confirm that their entry point was created? Yes? Okay. So at this point, you can also start checking that your CLI does what it is intended to do, right? So in this case, I want to confirm that if I give it a file name that is too short, that it will have an error. So the way you would call your entry point is the positional arguments are going to be grabbed as file names. So if I just put x.py, notice that that file does not exist, but my check doesn't need the file to actually exist, right? I'm not reading it in. I'm just looking at the name. So here, I'm going to do this as if it doesn't exist. When we check it with the actual pre-commit hook part, it will need to exist, but here it doesn't. So I can say run the validation on the name x.py, and you can see that it reports that the name is too short, the minimum length is 3, and it's reporting that the file that it was offending was x.py, right? Because I could also call like ab.py, abcde.py, right? And in this case, it's only going to report on 2 of them. So any number of arguments will be passed through. And we can also use that min length argument. So I can say min length is now 2. And now only x.py is too short. All right, so now we're at the final step of the creation of the hook process. And now is basically when we have to create that file I had mentioned before that tells pre-commit, here are the hooks, this is what they need to be, what needs to be installed for them to work, etc. So this is the pre-commit hooks.yaml file. So before was pre-commit config, which said which hooks we want to run. Pre-commit hooks declares hooks that exist in the repository. Okay, and this one is just a list of hooks. So there's no outer label like we had repos section. This is just a bare list and YAML of the hooks. So the ID, which we were familiar with already, is what people will declare when they want to use your hook. So here's, you just name this whatever you wish your hook to be identified as. So this is an example from the exif stripper. So it's called strip exif when people declare it. You provide a name. So if you've noticed, for example, we are using rough-check, rough-format, but when we ran the hooks, it was always rough-check, rough-format. So this name is the display name that will actually show up in the output when the hooks run, right? So for example, here, you see there's a space here. So whatever you put as the name will end up here for your hook. Now the description is not something that will be shown anywhere. It's going to stay in the file. So this is optional, but I would definitely recommend you put it there because if people are going to be trying to figure out or if your hook exists or you want to remember later what's the distinction between the two things, you can just put that in there. Then entry, this is what pre-commit will actually call to run your code. Okay, so in this case, I'm pointing it at exif stripper, which was that entry point that we all just walked through and created, like the validate file name one. But you can actually put arguments in here. So for example, I think if you look at rough, like rough check is actually rough plus some arguments in here. So you can configure it that when you want to call a certain hook, that it should already be baked in with some arguments that can't be overridden. So if you wanted to do something like that. So whatever is on there is going to be run as the command. Now the language part is not what the files you're going to be operating on, but it's actually telling pre-commit how it's going to be installing it. So this is saying that this is written in Python, so you need to use Python tooling to install this thing, and there's going to be Python dependencies potentially, but you use Python to install. Now, the fact that this is here also means that we can use other languages, right? So you could write something in Go, but assuming Go is on the machine already, and then you declare that. And the final thing I have here, this is optional. So if you wanted your hook to only run on certain types of files, you can declare that in here. So if you click the word types up there, it has a link to like the ones that are available. There's a separate package that they use to determine something like this. So here, it only makes sense to remove exif metadata from images if the files are images, right? The same thing, like if you're working only on Markdown files, then you would want to tell this only to trigger on Markdown files. It's wasting time if you were having your hook determine, oh, I don't run on these files, because that's already later in the process. So again, optional. Okay, so now you're going to make your own pre-commit hooks.yaml file. This is at the top of the repository, this is the root, just like the pre-commit config one was. At the bottom, I have a command that you can use to validate that that file is in the correct format. Again, very confusing error messages, so likely the YAML is malformed, but feel free to call me over if you can't figure out what's going on. The other important thing to note is this here. So depending on how you're doing your check, you might need things to run in sequential order and then group them all together and do something at the end. So for example, if you're creating a table of the results, you need to calculate the dimensions of the table, and so you need to know everything that's going to be in the table before you make the table. So this is not the default. So by default, what pre-commit is going to do is going to run multiple processes at once, and you don't have control over how many files are sent to each one. So you might try to commit 10 files. 5 of them might want in run process, another gets 3, and another gets 2. And then each one of them will be printing their output. Right? So if you wanted to do something with the output of all 10 at once, then you need to declare that you need to run in serial. If you're not sure whether you need that, feel free to talk to me. But if you're making a table, it'll be very obvious because they'll all be different sizes and it will look really weird. Okay, so also this link will have some other options of configuration that you want to do. Like maybe, like the file types I was saying, maybe there's certain things you want to exclude. Even if you want to declare that it doesn't run as a pre-commit but pre-push or something, that can be done in there. So let's dive into this one. And don't worry about trying to test if it's a hook yet. We'll get to that in the next step. So just get this file going and get it validated. So I think some interesting options. Right, so files, you can specify which like regex of files they should run on automatically, which it's interesting when you think about like maybe you want to say, oh, this runs on like README and license, like the standard files you would expect to have. Maybe that's a use case for this. Exclude we saw. Types. The very interesting thing here to note is that types is an and. So when you have multiple things, if I did image, comma, markdown, it would not run on anything, right? What image is also a markdown file. So you have to be very careful if you're saying it can run on any type of these files that you actually need the types or. So that's a potential gotcha in there. They let you exclude the types, which is interesting. Here's the require serial thing I mentioned before. And yeah, stages is what I was saying about if you don't want this running as pre-commit, you can actually say I want this as like checking commit messages, which are is a tool that does that exists already, or something that runs as pre-push is also possible. So let's go back. Okay, so for the example that I'm showing with the file name validation with the length, this is all we need for the pre-commit hooks YAML file. So I'm just going to copy this into the file. And then, very important, if you haven't done it already, you will fail on the next exercise if you do not commit this, because it will not work. So do that now if you haven't already. Okay. So again, most of this stuff you notice is pretty much exactly the same. The ID, the name, the entry. That is kind of a pattern that can happen very quickly when you're just making these small little hooks. I did want to show you for rough pre-commit. So if you go and you want to see like what some other things look like. So this is what I was saying before about rough check, which is what we were using. Notice how the entry here is not just running rough, right? It's running rough, running specifically rough's check, right? And then also passing this force include. So you can formulate whatever type of command you need in here. And you could also potentially, maybe you have like 3 different versions of your hook. It's all one CLI, but you specify different settings. And that's kind of the model you have here. So this is a nice example of just seeing that. And here's what I was saying before about require serial being true. So because rough gives you a report at the end of all the findings, it needs to be able to tell you that there were 10, unused imports across all the files. In order to know that it was 10, it needs to have the collective result from all the files it looked at, right? So anytime you want to have an aggregated summary of the findings, you're probably going to need to do require serial. Okay. So now let's talk about how we can actually test that the hook is now configured correctly. So one way is you can use another part of the pre-commit CLI, which is the try repo command. And this lets you use the hook within the repository that you're creating the hook. And there's a link to how you would do that. And then the other option is you could use a separate repository, and you could, in the pre-commit config over there, point to your new repo. The catch on that one is you need to push up your changes, right? Because it's going to clone it. And then in that case, you point to the revision at the commit hash that you're testing. You don't need to go and tag every single time you want to change. You just point at the commit hash. And then on that other repo, you would just do pre-commit run, and then you can check that it's working. So both of those will give you what you need. And you are free to choose which of those you would like to do. And I'll just show for the toy example I've been building here. Okay, so the first thing, right, you may have noticed that you need to create the files to run on this time. So for my check, I have to create the x.py. So I'm just going to use touch. Okay, so now I have this x.py created, and then I can actually go about testing with pre-commit try repo. And some of you also struggle to find this little bit that you need to tell it the files, right? So just like when we did pre-commit run, if you don't have anything staged or anything to run on in the first place, then you need to give it something to actually run on. So here I'm going to give it x.py. Okay, and we see it failed, and that is exactly what we expect, right? I want to just go over what's going on in the output of that. Okay, so the first little bit, initializing environment for, you notice the two periods, right? One of them is dot, the repo, and the other one is the period at the end of the sentence. It's unfortunate, but that's what's going on there, okay? That's the equivalent of what we saw before when we added a new repo or we changed a version where it says, oh, initializing environment for rough pre-commit, right? So it's doing the same thing. It's seeing our repo, it's seeing what it needs to install, it's creating that virtual environment for it, it's installing whatever dependencies we have, and then the next piece is it's actually creating a pre-commit config file to run this on. So if you look, this section here is exactly what we had in the beginning when we were doing the pre-commit config file, right? We have the repos section, and we have our repo only one here, which is dot, the revision. This is the commit hash for the last commit that I made. And that's why I was saying if you don't commit, it won't work because you won't have that file. The pre-commit hooks file won't exist. And so this will be not useful and it won't be able to build it, okay? And then it's pulling out the hooks. We tried in the back, if you have multiple hooks defined, it will actually run all of them in here. So you can test them all on a single file. Okay, I went over that. Okay, and then again, we have the bit that we've seen before. At this point, it's installed everything in the virtual environment. It's created the config, and now it's actually working on setting up for the commit. So again, the double dots, and then it runs the check itself, and it fails, right? Because X is too short of a name. You may also have struggled trying to get your extra argument in here. Like, how do you pass min length equals 3? You can't do it through pre-commit try repo. So what you'd actually have to do is go in here, and you could do something like this, like min length and then 2. And then I'd have to save this file, commit it, and then do try repo again. So that's the downside of the try repo part, but it's really not much different from the other side where if you use a new repo, because then you now also have to push up the changes, right? So, but that's how you would go about doing the checks. And again, the revision, right? So where before we were using tags, in this case, it's using the commit hash for your last commit. So you don't need to tag it every time. Okay. So at this point, we all have hooks that work, hopefully. And at this point, I'm just going to wrap up by talking about your next steps at this point. So one of the things would be, how do you maintain your hook? So as we saw throughout this process, there are several points of failure where things can go wrong, right? Maybe your check function isn't working. There's something buggy in your CLI. You don't have the correct config in your Pi project. You're missing dependencies, or your hooks file isn't declaring something as it should, right? So there's lots of layers that things can go wrong. And so this is why we really need to have a test suite in place. So tests for your check function, tests for your CLI, and then also you can use this try repo stuff in your CI as a check. So if you push up any changes, you can have it run try repo and confirm that maybe you just want to check, does this still work? Does it still run correctly without error? And then also you want to be testing on different operating systems and Python versions. So you would want to set up a test matrix to confirm that when you state 310 and above on all systems, that it actually is 310 and above, and maybe it should work on Windows and Linux and Mac and all that, and not just one of them. And so you would have to have those kind of test cases. And then also you can use pre-commit to run the hooks in the CI, like I was saying. You can use try repo, or you could maybe have other repos that are pointing to it as well. But you definitely need to have those checks in place. At the end slide, I have some links to some examples with XFStripper and some small code bases that you can see how this could be done. Okay, so now that you would have your testing logic, the next thing you would do is you actually have to document that your code, or that your hook exists and how people would use it. And this is what I was saying in the beginning, how pretty much every repo that you come across that has a hook will have something like this on there. So you basically can have your minimum section that needs to be placed into the YAML, and you would provide that in your README or your documentation. And so someone finds your hook and wants to use it, they simply copy and paste that logic in. And if you have additional arguments that they can configure, different ways of using the tool, you can put those as different examples, and then people can figure out which one to use. And at this point, then you can share that this hook exists if you want to, right? Is the second you've published it on GitHub, it's public. Anyone can already be using it at that point. We saw you just point it at the repo, and it goes already, and it's downloading, and it's using it. But it's not so easy to find them necessarily. So the logic that they give on the pre-commit website, it's basically looking, pretty sure, for that pre-commit hooks.yaml file. So if you want people to use it beyond just occasionally finding it, you might want to talk about it like at a conference or a blog post, tweets, whatever. And you might also want to consider publishing it to PyPI. So in some cases, it's useful beyond just being a pre-commit hook. Maybe someone wants to run just on their code on their own without committing, or they want to run it in CI without having to install pre-commit. Those are all possibilities. And I've also linked to some additional things that you would have to do. The pyproject.toml needs more metadata if you want to publish to PyPI, but there are good resources out there to walk you through that. All right, and then wrapping up some good to know things here. So we didn't cover how to actually do this, but we talked about how NumPyDoc validation and rough are able to use the pyproject.toml to look for settings that they have. So that might be something that you want to do. If your tool is more robust, maybe there's some settings that you want to be able to set globally, and you can figure out how to put that in the pyproject.toml. We spoke a little bit about this when I was showing how rough has it. They have multiple hooks in the repository, so rough check and rough format. The pre-commit hooks one we started with also had multiple IDs, right? So if you have multiple versions of your hook that you want to expose, you would just create multiple sections in your pre-commit hooks.yaml file. And again, they can be run at any stage that's supported by pre-commit. And if you wanted to play around with moving yours to a different stage, you can visit that link. A common other stages are pre-push and also commit message to verify, like if you have style requirements on how the commit messages should be formed, you can do that as well. And again, they support any language that is listed over there, with the caveat that it has to be on the machine already. It's not going to go and install Go for you. Okay, and then here are those references that I mentioned, so you all have access to the slides, so you can check this out later. At this point, I'm going to wrap up, and we'll invite you all to come and share what you built. So I hope you enjoyed this. On the left, you have a QR code to provide some feedback on this workshop. You can either scan it or just click it. And on the right, there's links of how you can follow my work and stay up with what I'm doing. But thanks for your attention and your participation.